All right, so this video is 7.3, and it's one of my favorite lessons because it deals with the Pythagorean theorem. So the first thing we're going to do is kind of go through and look for the square roots, and you're going to notice a couple of things. Number one, if I look here, and I have the square root of 140 or 1.44, if I move this over two spots, I'll have 144, and then of course the square root is 12. So if I want to go over, because I'm multiplying two things together, so let's just write this down here. So if I have 12 times 12 is 144, then 1.2 times 1.2 should equal 1.44 because I'm moving them over both one spot from where it was originally, right? For a total of two spots. So let's just see if that works. And it's 1.2. This one here, it says plus or minus 900. So that would be plus an answer and minus the answer. So in this case, it'd be 30, plus 30 and minus 30. This one here, it's the square root of 2, or square root of 4 is 2, and 9 is 3, so it's 2/3. This one here, it has a negative sign, so it'll be 441. The square root of that, of course, is negative 21. Again, I have the positive and negative here, so it's going to be more than 20. It's going to be around 24, 20, 23. Let's look. So plus minus 22, sorry. But I have both plus and minus here because I have both signs here. 2,500, that would be minus 50. So we're basically going to look at how are the lengths and sides of a right triangle related. And if I think about it for a moment, I basically have, for any triangle, let's go back to one here. If I look at a triangle, I have these things here, and I have a leg, and these are the shorter pieces, and I have the hypotenuse, right? And if I have the leg, and the hypotenuse, they're all related. Now the hypotenuse is always the longest side, and it's always opposite of the 90-degree angle. And if I think about that for a second, it says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So basically what that means is if I have a triangle, and if I go through and I figure out what this is equal to, let's just say it's x, then when I would take this out, and this of course is a square, so it'd be x times x, right? So this is x squared. This here is y. So when I make a box here, this is going to be equal to y squared, right? Because y times y. And what we're saying is that I could take these two boxes and kind of smush them together. Let's smush them together so I got one bigger box. That area should be the same exact area as this one here, because it's like z times z, which is z squared. Now I purposely use different letters, but I could absolutely use the formula a squared, b squared, and c squared if I just would change these x, y, and z to a, b, and c. It means the same thing. The area of the legs, when I add it together, should equal the area of the hypotenuse. That's all it's saying. So if I look here, I'm going to have my, let's do this here. I'm going to have my 6 by my 8, right? So I'm going to make my triangle. I'll have 6, I'll have 8. I'm going to extend this out and make a box. So it's a 6 by 6 box, right? And 6 times 6 is 36. And 8 times 8 is 64. And all together, when I add that up, I should get 36 plus 64. And that should add up to 100. So this whole box equals 100. Well, if that's the case, if the whole box is equal to 100, that means that something times something has to equal 100. So I have to find the square root of 100. Well, if I think about that for a second, that equals 10, right? Because 10 times 10. So this length of C, in this case, C equals 10. And that's what it is. Now, in terms of the formula, what I did is I did this. 6 squared plus 8 squared equals C squared. And then I have it, I go 36 plus 64 equals C squared. And then I have 100 equals C squared. And to get C by itself, I have to do the square root, right, to both sides. And I'll have C equals 10. So just so you can see the visual, and then you can see the math behind it, like what we write down, this is how it's all connected. So I want you to pause for a moment and try to replicate this for 2, 3, and 4. All right, so when you do that, when you pause the video, you should be able to see what these are equal to. This one here is going to be 5 times 5. Oops. So I'll say 5 times 5 plus 12 times 12 equals c squared. So I have 25 plus 144 equals c squared. And then this equals 169 equals c squared. Square root, and I have c equals 13. And you can do the other ones for these down here, but same kind of steps. This one here, find the length of the hypotenuse. It's the same exact thing. It's 5 squared plus 12 squared. This is the one where I get 13. All right, so here we go. I have my a squared, b squared, and c squared. My 169, so that's equal to 13. So let's do a few more here. So I have my 8 squared, my 15 squared equals c squared, right? I might draw my squares. I'll solve it. Equal to c squared. In this case, c equals 17. For this one, this is an interesting one. Let's take a look at this for a second. If I take 2/5, let's write this one out. So I'm going to take 2/5 squared plus 3/10 squared equals c squared, right? And so in this case, this would be 4 25ths plus 9 100ths equals c squared. Well, I want to add these up, so I need a common denominator. So this will become 16 hundredths plus 9 hundredths equals c squared. And then when I do this, I'm going to have 25 over 100 equals c squared. So I do the square root of both these things here. So I have 5 over 10, or 1/2. So even though it's fractions and it looks like it'll be trickier, it's the same thing over and over again. Where it does get a little tricky, but it's really not if you know what you're doing, is let's say now that instead of solving for the hypotenuse, I'm solving for a leg. So I'm going to go through here, and let's just write out the formula again. Again, I know that it's my a squared plus b squared equals c squared, right? And I know that my a squared, I don't know what it is. I'm going to keep it as a squared. I know my b squared is 2.1, so I'm going to put down 2.1 squared. But now I have my c squared, don't I? So I have 2.9 squared. And if you understand mathematics, this is actually still very easy. I'll have my a squared, and then I have to think about what 2.1 times 2.1 is. So let's just do that real fast. So if I have 2.1 times 2.1, I'll have 4.41. So I'm going to write that down. So plus 4.41 equals, and now I have to do my 2.9 times 2.9, right? Same steps. So I'm going to write that down. So 2.9 times 2.9, and that equals 8.41. So I'll put down 8.41. Well, now I want to solve for this a squared, don't I? So think about how you solve any equation. First thing I do is I draw my line. I'd subtract 4.41 from one side, subtract 4.41 from the other side, and I'll have a squared equals 4. So then a has to equal the square root of 4, which equals 2. So my length here is equal to 2. So notice that even though you memorize this formula, a squared plus b squared equals c squared, you could solve for all letters, depending on what you're given. Try another one of these. So here's this one. So it says you're playing capture the flag. You are 50 yards north and 20 yards east of your team's base. The other team's base is 80 yards north and 60 yards east. How far away are you? So I have this right here. And all that I'm doing is I'm really just dropping a line here, right? And if I drop a line down and over, I now could solve for my legs and then figure out my hypotenuse, right? So pause the video and try to figure out what you think you would do here. So first of all, I know that this distance from here to here is 30 yards, right? Because I know that 50 plus, or 80 minus 50 is 30. And I know that 60 minus 20 is 40. So I have these legs. So it'd be like 30 times 30 and 40 times 40. And I get this here, and I get like 2,500 altogether. And the square root of 2,500, of course, is 50. So this has to be 50. Now try to do this one here. Again, you have the hypotenuse, and you're solving for a leg. This one here, you have the hypotenuse, you're solving for a leg. All right, so here's what we're going to do with this problem. It says that a guy is attached to a wire 24 feet above the ground. So I'll draw a little thing here. I know that this height is 24. And I know that the length, it says, is 10 feet from the base. So I'll put down 10. I'll make my squared, because it's a squared plus b squared, right? So this area and this area here. And I'll have 100 units squared. And this equals 576 units squared. And when I add those two numbers together, these two bases, and combine them, I should get a total of 676 units squared. And I got to figure out the square root of that. So let's go through and do that. So if I go through and I do the square root of 676, I get 26. So that's my answer. So this is equal to 26. And that is my answer. And that's really the lesson.